Alright, let's do the refresher differential equations of LC Alvarez Senior Edition. I am Professor Alfredo Gil Alvarez Jr. Alright, let's start this. Let's start right here. Let me get my pins here. Alright, so now, Wallhog's logistic model solve the separable differential equation with initial condition P is 0 equals 80. Alright, so what we're going to do is dp dt equals 0.2 p parentheses 1 minus p over 4,000. We're going to solve this separable differential equation. First of all, I'm going to divide this side by p times 1 minus p over 4,000. Same thing over here on both sides. Divide here and here. Notice that these are going to start canceling. So let's go next page. You'll see. So now what's going to happen is you're going to have dp dt over this. These will cancel. P's cancel. Those cancel. What's left over is just 0.2. Other side, you have dp dt over p times that. I'm going to rewrite this as the same dp dt, p times that over 1. See the 1 here? Now we have one fraction on top and one fraction on the bottom. Get the reciprocal of this. So you're going to have dp dt right here. And this right here, I'm just going to flip it around, upside down reciprocal. There it is right there. So dp dt times 1 over p times 1 minus p over 4,000 equals 0.2. Now, the next step. We have 1 over p times 1 minus p 4,000 times dp dt. And multiply both sides by dt and dt. So now, what happens now? These will cancel. So we have 1 over this, dp equals 0.2 dt. Now, what we're going to do, we're going to write this as, see the 1 right there? 1 becomes 4,000 over 4,000. That's a 1. I rewrote this. Now, this I can put together because they have the same denominator. See the 4,000 and 4,000? So 4,000 minus p over 4,000. Okay, and what I do here, I just rewrite this right here. Let me write this here. Rewrite. Okay, that's what I did right there. And that magic 1 right there. Alright, now, one denominator, one big fraction, 4,000 minus p over 4,000 times p equals 0.2 dt. Now, the next step, 1 over 1, p times this over that, dp is that. 1 over 1, and I write this p times the top, p times 4,000 minus p, parentheses, over 4,000. Get the reciprocal of this, which means 1 over 1 times 4,000 over p times, parentheses, 4,000 minus p dp. Now, as we look at this 1 over 1, well, it's just there. It's gone. So now we have this. So we're going to have to integrate. Take the integral of this side and the integral of this side. The integral of 4,000 over p times 4,000 minus p dp equals the integral of 0.2 dt. Now, what's going to happen? We're going to have to break this down. This 4,000 minus p equals a over p plus b over p. We rewrite the left side with partial fractions. Alright, so there's the problem we're trying to solve. Multiply by the LCD, which is p, 4,000 minus p, p, 4,000 minus p, p, 4,000 minus p. We multiply all these by that LCD. These cancel. The p's cancel here. And all these guys cancel here. The p, 4,000 minus p, 4,000 minus p. Now, what's left over is 4,000 equals a times 4,000 minus p plus b times p. Let p equal 4,000. Put it in that formula. 4,000 minus 4,000, 4,000 here. That's going to be 0. 0 times that is 0. 4,000b. 4,000b plus 0 is going to be 4,000b. Now, divide by 4,000, divide by 4,000, so b equals 1. Now, we know what b is 1. Now, back to the original problem. 4,000 equals a, parentheses 4,000 minus p, plus b times p. Let p equals 0 this time. So put a 0 for the p, a 0 there. That's going to be 0. A times that is going to be 4,000a equals 4,000. Divide by 4,000, divide by 4,000, so a is 1. Now, we have a and b. I know that 4,000 over P times 4,000 minus P equals 1 over P plus 1 over 4,000 minus P. So let's rewrite this. The integral right here, original problem, we're going to write this using this formula here, the partial fractions, as 1 over P and 1 over 4,000 minus P. Now, to integrate this, let's rewrite this. This is negative 1 to negative 1 is 1. Bring the negative 1 right here, keep 1 over here. So now we have 1 over P minus negative 1 over 4,000 minus P. Because the derivative of negative P is negative 1. Derivative of P is 1. So now we can use this formula right here. If you have the derivative f prime of x over f of x equals ln of f of x plus c, and if you have the integral of a constant, 0.2 is a constant, a dt is going to be at plus c. We're going to use these two formulas in here. So this is going to be log of p, this is going to be negative log of 4,000 minus p equals 0.2t plus c1. Call it c1. Let's call it c1, okay? First constant. Now, log of p minus log of 4,000 minus p equals this, c1. So now what we're going to do is rewrite this using the formula log of a minus log of b equals log of a over b. So we're going to use that formula right here. So log of p over 4,000 minus p equals this, from log of a minus log of b formula. Now, what can we do with this? Well, we can take e to the power, e to this power, like that. So what's going to happen when I do that? Well, you have e to the ln. There's a formula for this. E to the ln of that, and we'll do it in a second. And e to this. So e to the 0.2 c is e to the ab plus b is e to the a, e to the b. So write it down as 2. E to the 0.2t, e to the c1. Now, let c e to c1 become some other constant, c2. Let's call it c2 now, okay? c2. So now I'm going to replace this right here with c2. So we have e to this equals e to the 0.2t times c2. Now, what we're going to do is let's rewrite this. Let's rewrite this as e to the log natural of p 4,000 minus p in there equals c2. Rewrite it. c2 times this. And e to the log of this is just this right here. There's a formula for this. Okay, from college algebra land. So e to the log of that is just this. Now, we have multiply both sides by magic. E to the negative 0.2, e to the negative 0.2, both sides by that. This right here, you're going to put them together. E to the 0.2 minus this right here. And if you put those together, it's going to be e to the n minus n, that there. But that's going to be a 0. E to the 0. E to the 0 is going to be a 1. We're going to put a 1 in a little bit, not right now. So this over here, multiply on top, we have this on top. So we have e to 0, and that's going to become a 1 on the next step. Okay? So there it is, see it? E to 0 is a 1. So now we have p e to the negative 0.2t over 4,000 minus p equals c2 times 1. That's c2. So now what are we going to do? Now we're going to go ahead, multiply by 4,000 minus p, 4,000 minus p, both sides. These are going to cancel. Look at this right here. Right here. They cancel out nicely right there. So we have p e to the negative 0.2t equals 4,000 c2 minus p c2 right there. Multiply this out. Now what are we going to do with this? Next step. We're going to go ahead and add PC2 to both sides. So these are gone. So we have p e to the negative 0.2t plus pc2 equals 4,000 c2. So now I'm going to factor. I'm going to factor right here. Okay, and by factoring I mean p times this one is this right here, and p times that is pc2. See that right there? P times that is that. P times that is that. So I just factor the p out. Now I'm going to divide by e to the negative 0.2t plus c2, e to the negative 0.2t plus c2. These are canceled. So left over is p equals this right here. So now in the next step, here we go. P equals 4,000 c2, e to the negative 0.2t plus c2. Now, I'm going to multiply by magic 1. 1 over c2 and 1 over c2. That's a 1. So it's not going to change anything. So 1 over C2 in the numerator and in the denominator. So on top, we're going to have 4,000 C2 divided by 1 over C2 e to the negative 0.2t plus C2 over C2. Now, we can reduce these, simplify. This is going to be a 1, and this is going to be a 1. So that's what we have left over right here. 4,000 times 1, which is 4,000. P equals 4,000 over 1 over C2 times e to the negative 0.2t plus 1. Now, we're going to rewrite this one more time. Another magic step, of course. Of course. How is it going to go? Let's see. I'll tell you how it's going to go. So what we're going to do is we're going to let C, big C, equal 1 over C2, another constant. Okay? So right here, for this one, I'm going to replace it with C. P equals 4,000 over C e to the negative 0.2t plus 1. Now, let's use the initial condition of the differential equation that P of 0 is 80 to find letter C. So let's put a 0 in there. So 0 for the t. So 0 times that is 0. E to the 0 is a 1. 1 times that is C. So this is going to be C plus 1 on the bottom equals 80. So 4,000 over C plus 1 equals 80. Rewrite it. 4,000 over C plus 1 equals 80 over 1. I just rewrite this. Two fractions right there. Rewrite it. So now, what's going to happen is we're going to do cross multiply right here. The next step. Okay? We're going to cross multiply these guys, which means this way and this way. So we're going to have 4,000 times 1 equals 80 times C times 1. 80 times C is 80C. 8 times it's going to be 80. Subtract 80 from both sides. So we're going to have 3920 equals 80C. Now, divided by 80, we have 49 equals C. So I know what big C is. What is it? It's a 49. Now, put it back in the formula. This is the formula we had. We know that C is 49. Substitute in there, 49. So P equals 4,000 or 49 e to the negative 0.2t plus 1. The formula, the logistic model is going to be P of t is going to be 4,000 over 49 e to the negative 0.2t plus 1. Now, using the graphing calculator, let me get a graphing calculator here real quick. Here we go. Alright, it says to use it. So let's use it. It says put P of 0 in this formula, which becomes this. So let me put that in my machine here. Hopefully, we have 4,000, 4, 1, 2, 3, divided by parentheses 49, second ln, parentheses negative 0.2, parentheses 0, put 2 zeros there, 0, 0, plus 1, plus 1, close parentheses. Alright, I got 80 when I do this. Let's put it over here. We get 80. So, when I put this in there, in my calculator, I got 80 for this. Got it? So now, let's do it. Let's go to the next page. What would happen if you put a 10 in there? Second ln, we write it, put a 10 in there. We get 524.148,238. There it is. So, using your calculator skills, you need to put these numbers in there. All these numbers in here. And eventually, you're going to get these numbers right here. That number and that number for P of 10, P of 20, P of 30. Keep going. P of 40, P of 50, P of 60. There's the numbers. So finally, P of 70, P of 80, P of 90. And we have points. Here we go. At 0, we got 80. So after how many weeks? 0 weeks, there's 80 hogs initially. Then at 10, there was 524. At 20, there was 2,108. At 30, there was 3,566. At 40, there's 39.35 and 50, and then all the way to 90, which is 3.999. So eventually it's going to level off, this logistic, as they start eating all the food, water, corn, whatever you have out there in your fields, in your farm, ranch, whatever. The grass going to go exponentially like this, and it's going to be a logistics and it's level off right there. Because they're running out of food, they're running out of space, they're running out of water, it'll just level off. So it's going to level off where? At 4,000. That's where it's going to stop. The population will end at 4,000 wild hogs in your, I guess they're like pets, I guess. Not pests, pets. Anyway, there's a logistic model for this wild hogs using differential equations, refresher differential equations. Thank you. This is Professor Alfredo Gil Olivares Jr. Good luck in your differential equations refresher. Bye. Have a nice day. Good luck, good luck, good luck, good luck.